This conference will now be recorded.
So we got dynamic programming for the day, and today we're gonna understand that how you can write an effective code, and we'll see that where you can exactly use dynamic programming. So typically, this is going to come up with something known as those who cannot remember the past are condemned to repeat it. Right. So let us try to see what I'm putting up here. So we're gonna understand what is dynamic programming. Thereafter, we'll see some characteristics of dynamic programming. We got overlapping sub-problems. So there are some, there's a problem. So you divide the problem into sub-problems, and they are quite similar, or they are overlapping. Then the optimal substructure property. So they have a structure through which we're going to resolve it, right? Then we'll see the different methodology to solve the problem using dynamic programming technique, right? So one is known as memoization, some cache, right? The second one is tabulation, where again you're trying to maintain a cache but in a tabular format. So this is what the content is, and we'll see how the things can be now done. So when we write down something known as 1 plus 1 plus 1 and so on and so forth on a paper, right? Or if you can see it's in front of you. So how you gonna work on it, guys, right? So what can be the way that you'll be working on it? So that's quite equal to something known as 8, right? So the moment I will write another 1 on the left or on the right, you will very quickly get to know that the answer is 9. So how would you know that this is going to be so fast, right? So you are basically trying to memorize the previous solution in your head, and thereafter you are able to answer that, okay, the new answer is going to be 9, right? So dynamic programming is a way where you remember all this stuff and you save the time later. So algorithmically, when I'm implementing something, so we always need to ensure that we land up in saving time. So dynamic programming is a way that you can save your algorithms time by making sure whatever you have computed before or earlier, you're trying to save it somewhere. You're trying to come up and kind of maintain some cache in your program. So guys, can I get a smiley as an acknowledgement? All right. So what is dynamic programming? It's a method for solving a complex problem by breaking down the same into simpler subproblems, right? So we always have seen various different algorithms that how we can kind of do a divide and conquer, right? So you can have a problem set, you can divide your problem set into subproblems, right? So this is one of the major you can say part of your dynamic programming. So the sub problem will have a solution, and you're gonna save that solution into some data structure, for example an array or a hash map or a dictionary, right? Typically in Python, right? So you're gonna save that solution so that if the same sub problem occurs again, we should be able to use the result from it. So when your sub problem is supposed to be solved, right? So you're going to have solutions in an indexed approach. So for example, there can be a key value pair, right? That okay, this sub problem has this solution. So next time if you find the same sub problem, you will not recompute the solution, rather you're going to use the value of that solution, and hence you're going to save your computation time. So guys, in the dynamic programming, there is a technique, right, that we're gonna store the solutions of sub problems instead of recomputing them, and this technique of storing the solutions is known as memoization, right? So memoization is a dictionary a word basically, where you're trying to create a kind of a cache, right, to store your data temporarily while you're executing your program. So the dynamic programming will have characteristics, right? So there's a problem, and you need to first of all see whether you can implement dynamic programming there or not. So how are you going to make up and identify the same? So in order to identify that, okay, the program which you are going to solve, the problem which you're going to solve is going to have this, kind of characteristics or not. So the first characteristic is overlapping sub-problems. So there are sub-problems, right, which are actually the smaller versions of the original problem. Now the example is the Fibonacci numbers, right? You solve it recursively. So any problem which is going to have overlapping sub-problems, right, you need to find the solution for the same. Let me show you how we are trying to work on this concept called overlapping sub-problems. So if you see the dynamic programming characteristics for this Fibonacci, if you see Fibonacci of 4, I need to calculate Fibonacci of 4. You need to know the result of Fibonacci of 3, Fibonacci of 2. For Fibonacci of 3, you need to know the result of 2 and 1. For 2, you need to know the result of 1 and 0. For 2 again, 0 and 1. Now there are overlapping sub-problem patterns. Fibonacci of 2 is executed again and again. Fibonacci of 1 is getting executed again and again. 0 is getting executed again and again. Now this is known as overlapping sub-problem pattern. So can I get a smiley as an acknowledgement from all of you? Are we clear, guys, still here? All right, guys. So let's see the next part of our discussion here. What we'll do is we'll try to write a problem and solve this problem, right? So let's try to see how we can write this Fibonacci problem, but I'll take this one more slide before that. So the second approach here for us may be the optimal substructure property. Now any problem will have an optimal substructure property in case the overall optimal solution can be constructed from the optimal solutions of its subproblems. What we're trying to say is, if you want to calculate the Fibonacci of n, right? So it is always the solution of n minus 1 plus n minus 2. So you are basically reducing the subproblem which is having the size n of the size n minus 1 and n minus 2. So you can implement dynamic programming in case you can divide your problem into subproblems, and when you have divided the subproblems, there is a pattern called optimal, this overlapping subproblems, right? So two of the characteristics, these are supposed to be identified in a problem. Only then you can implement dynamic programming. So let me try to write a solution first of all. So we'll write a basic solution to calculate the Fibonacci series, and we've already seen, I think, So we'll try to write it recursively. So this is a very basic, example to begin with dynamic programming. But dynamic programming is all about solving even more complex problems, guys. All right, so I'm going to write a new Python file. So guys, I would like to come up and solve the problem with respect to Fibonacci. So I'm not going to come up and kind of print the Fibonacci series, right? I'm gonna do something else. I'm gonna calculate the Fibonacci for the number. So I'll say define Fibonacci for a number. So we'll take the number as input, right? In case the number is less than 2, I'm gonna come up and say return back the number. So the other way around, right? I'm gonna say return me Fibonacci of number minus 1 plus the Fibonacci of number minus 2. Guys, this is how you can come up and solve your problem with respect to your Fibonacci numbers. So I'll just come here and say main. Let's see. All right, so now let's say you want to calculate the Fibonacci of some number 5, right? So there is a result and we'll come up and say Fibonacci of 5. So print me the result. So it says the Fibonacci of 5 is 5. And when I say more easier approach, Fibonacci of 7 is Fibonacci of 7. So guys, is this part clear to everyone? What we did here? Can I get a smiley? Did we understand what we did? So when you are actually trying to put up this problem statement and we know the series, they're gonna work for us in a way 0, 1, 1, 2, then the 3, then the 5, then the 8, 13, so on and so forth, right? So this is your 0, 1, 2, 3, 4, 5, 6, and 7, so on and so forth. So you got this basic problem statement. I'm not printing the Fibonacci series, but I'm printing the perfect number, right, with respect to the position which you're going to pass, right? For number 7, the Fibonacci is going to be 13. Now, what is the next thing which we have to come up and understand? So if you have this Fibonacci which you have already implemented, right, is it going to have the problem with respect to overlapping sub problems? That's the first thing which we need to see. Second thing was optimal substructure. So this is already we have done, right? So this return Fibonacci of number minus 1 plus number minus 2 is your optimal substructure property. Overlapping problem means what? So what I will do is I'll just come here and write a print statement evaluating Fibonacci of this plus this dot format number minus 1 comma number minus 2. So let us now run this program and see what's going to happen. So what we see is you wanted to come up and evaluate this Fibonacci of 5, right? For Fibonacci of 5, we are evaluating 4 and 3. Then we are evaluating 3 and 2, 2 and 1, 1 and 0, 1 and 0, 2 and 1, 1 and 0, right? So what we see is the same function call, right? Fibonacci of 1, 1, 1, and 1 is executed n number of times, right? So this 3, 3 is executed n number of times, 2 and 2 is executed n number of times, 0 is executed multiple times. So this is known as overlapping subproblems, right? So when a subproblem solution is recomputed several times. So the program exhibits both these characteristics. I hope this part is clear to everyone. I would like to get one acknowledgement again, guys, from all of you. All right, guys. So coming back to the presentation now. So the first technique which we are going to implement is known as top-down with memoization. So there are two different ways how you can implement dynamic programming in this kind of a solution, right? So in the memoization technique, what we do is we are going to first of all implement recursion, of course, right? So our major dynamic programs will be all recursive programs. Okay, so when we talk about dynamic programming, so you understand, okay, blindly it's gonna be a recursive solution. So there's a sub problem. We're gonna cache the result so that we don't end up in re-evaluating it multiple times. So we're gonna save the time, right, by fetching the solution of the previously solved problem rather than implementing. So we're going to see this same technique in our example of Fibonacci numbers, right? And we're gonna understand something known as a basic kind of a solution. So let me come up here and implement your dynamic programming with memoization. So I'll just come up here and create this session 38A. So the same problem statement which we already have, right? So we're gonna solve the same problem statement once again. So here we're gonna implement our technique called memoization, right? So this technique over here is memoization. Let's see, guys, how it can be done. To do that, I have the same function Fibonacci for a number. So I'll write down a list, right? So that this list for me is known as a cache, right? A memory cache. Now you can just say it's a memory, right? It's gonna be a list. And to begin with, this list over here, I'm just going to store some values, right? And these values, okay, so one more thing I would like to put up here. There will be some results which you're going to store, but what do you think, how many results should be stored? Now what I'm saying is, earlier discussion, what did we see was that for calculating this Fibonacci of 5, you got 43210, right? So this is what you have as in your kind of results which you are breaking down. So I'm going to take up this list and I'm gonna implement list comprehension. So let us assume the number to be -1. So for your let's say n in, or let's say for n in range of number plus 1. So implementing cache for our program. So I got this one basic list, right? So the moment you execute your Fibonacci function, in that particular function, you are going to have a list, right? Which has this value as -1. And from here, what I will do is I will further create this function called define Fibonacci calculate Fibonacci. And for this guy, I'm gonna take this memory and the number as input. And from here, I'm gonna return back your calculate Fibonacci with the memory and the number. So what we got recursive solution once again, but here you are doing some indirect recursion, right? You are executing a function, another function from the function. So what we did, we executed this function Fibonacci of 5. So you create a memory cache, and thereafter you executed calculate Fibonacci with the memory which you created here and the number for which you're trying to looking for a solution. Now what we do is, in case the number is less than 2, you return back the same number. But now we have to come up and see, in case you have solved the sub problem, return it from the cache or the memory. So in case we have earlier solved a problem, you give a solution from our memory cache. So let me show you how it's gonna work, right? So we're gonna come here and say, if your memory of this particular number is greater than or equal to 0, so we're gonna return this memory of number. And what I'm going to do is, I'm going to say memory of this number is equal to your Fibonacci of, now the function will change, calculate the Fibonacci of this memory comma number -1 and memory comma number -2. So lastly, you will say return me the memory of number. Guys, we are solving the same problem in the same way, but what exactly you are doing is, you are trying to come up and solve your problem by saving the solution in this list called memory, and the number is that particular index for us. So it means what? It means that we are going to have a solution which is supposed to be now saved temporarily in the list, and you're returning that solution from the list itself. And in case there is already a solution available, you return back from here, you don't evaluate. So from the previous part, you were doing evaluation on this. We'll write the same thing, evaluating Fibonacci of this on number -1 and number -2. So coming here, returning result for calculate Fibonacci of dot format. So memorize of the number. So guys, can I get an acknowledgement from all of you? Are we clear with what kind of implementation we have done? Let me put up once again. You will execute the Fibonacci of 5, but when you will execute the Fibonacci of 5, you are going to create a cache, right? So this cache which is going to be created is going to be 5 plus 1 6. So for your calculation of your Fibonacci numbers, right? So you executed another function, so recursive approach, but where one function executes the other function, and now the other function will execute itself again and again, right? Number less than 2, you return the number. There may be a case that the list which you created and which you're passing here has a solution. If it is going to have a solution, you return it right away. You don't compute. So you're by default doing a computation, but this computation is directly getting saved in this list, and you're returning the data from the list only. So let us try to first of all see what is. Now what you see is, so let us see Fibonacci of 5 here. Your first part, when you evaluated Fibonacci of 5 without implementing dynamic programming memoization, and here is the another part. So previously we evaluated Fibonacci 4 and 3, then 3 and 2, then you got 2 and 1, but when we came back to 1 and 0, so what you see is after these 4 instructions, right, we are returning back the results rather than doing a recomputation. This is after dynamic programming implementation, and this is before. Guys, can I get an acknowledgement of the smiley from all of you? Are we good to go? So I'm gonna put up this same over here in your 38A. So now, Noor, if I take by default the memory values as 0, it may be a problem for me to come up and do this check. I'm keeping the values as -1 because if I'll be evaluating Fibonacci for a number, right, we have to save the solution for it, and we know it cannot be -1, right? So that's the reason why I took this guy as -1. Good to go. So in case you find the index value as -1, you do the computation. But in case it is 0 or greater than equal to 0, you don't do the computation. So now we're good to go. Wonderful. So the next technique to solve the dynamic programming is going to be where you are implementing tabulation. So guys, tabulation is opposite of memoization. In memoization, we solve the problem and maintain a solution to the sub problems, right? So this is known as the top down. The memoization is known as the top down, right? So why we say it as top down? So typically you are trying to solve the sub problems first. So let me come up here and show what I'm putting up here. So in order to solve the Fibonacci of 4, till you don't reach 0 and 1, right? Till you don't reach the 0 and 1, you won't be able to solve your problem. So this is like top down, right? So in order to solve the problem for Fibonacci of 4, you're going from the top till the down, right? Now, memoization is a top-down approach, but when it comes to your implementation of dynamic programming with tabulation as the method, it is the opposite of your memoization. So, tabulation, in the tabulation, what we do is we are going to come up and somehow calculate and populate our table, right? So we're gonna create some a list. It's gonna be kind of a table for us, right? Maybe where we are going to append the data in the table, and then we anytime want the data, we get it from that table, right? Let me show you with an example. Thereafter we'll understand the term bottom up approach. So what we are going to implement here is known as tabulation. So guys, this is a different way of solving the problem. Let's see how. So what I'm gonna do is this Fibonacci here. I'm gonna create a DP list for me, right? So I'll say dynamic programming is an array. So 0, comma 1, right? So the first two numbers here, they are 0 and 1 for us. We know this, correct? So we'll say for I in range, so for I in range, you begin from 2, you go till your number plus 1, your dynamic programming dot append. So dynamic programming of your I minus 1 plus dynamic programming of I minus 2. So anytime we are solving the problem by taking the solution from the list, so you are kind of once again storing the data in the list, right? But this is where you are kind of maintaining the data in the list completely. You are not doing a recursive approach here, right? It's not a recursive approach for us, it's a direct approach. So if you wanna return the solution, it's gonna be dynamic programming of the number. A very simple and easier approach as compared to the previous approach. But yes, of course, when you now run this program, okay, so just give me a moment here. Let me check what exactly is the issue here. Oh, my bad. So guys, this is supposed to be a computation, right? So I'll just put them in the brackets. This is supposed to be solved, right? Just give me a moment. So dynamic programming is a list and DP of, yes. Here you are, guys, right? So DP of 5 and you want to evaluate dynamic programming of 7, and here once again you have solved the problem. So what we did, we actually executed this entire problem, and we actually kind of saved the sub problems in the list itself. So you maintain the table, so you are maintaining this kind of table. So this approach is the reverse, right? It's known as the bottom up dynamic programming approach. Means what now, right? You solve all the problems and you have them in the list, you have them in a kind of a table, and from the table you look up for that result and you give back the value. So guys, can I get an acknowledgement of the smiley? Are we good to go with these two problems, two solutions? So this is what is a quick introduction to dynamic programming. And now what you need to do is you need to come up and see these three sessions which we have done, right? So compare running time of these programs and share across the group. Okay, so Prabdeep is saying what is bottom up. So Prabdeep, when it comes to the top down approach, right? The top down is that you want to evaluate Fibonacci of 4. So you recursively break your program, correct? And whatever the problem is, the problem will have a solution. You save that solution in the cache. Now you don't have the solution for everything, right? Typically, so you are solving the subproblem and you are trying to maintain its solution. In case of, so why it is top down, right? Because you start from the 4 but you solve 0 and 1 first. So here what we are doing, we are trying to do the same job. We wrote a loop here where you are evaluating your entire Fibonacci series in this list called dynamic programming. DP is a list, or it's a kind of a tabular view for me. Now, when I say tabulation, it never ever means that it's gonna be a 1D array. So this means it can be a 2D array as well, 3D array as well, right? So here in the bottom up approach is you solve the entire problem first, right? You solve the entire problem. You got a list. From the list, you return back that particular result. So, guys, this is all for the day, right? And from tomorrow, what we're gonna do is we're gonna explore some more challenging programs in dynamic programming. And I would like to just put up this thing. This is what the future is for you guys. So if you are going to actually target some great companies, right? So you have to work on your dynamic programming skill sets. So I'll be doing 3 to 4 dynamic problems and their solutions here, right? So there is a list of more than 100 problem statements on dynamic programming. I'll share that, so you guys have to solve it in future. All right. So thank you so very much. I'll share this on the GitHub. All right, guys. Thank you so very much. So I push this program. So you just need to compare the program's running time. So when I say running time, it doesn't mean that you have to do me a bigger notation here. So you need to evaluate the time in the milliseconds, right? So use the time module in the Python and see if you are executing this Fibonacci of 5. Take a timestamp before this print statement and after this print statement and see how much time did the program took, right, to solve this Fibonacci of 5. So let me know, is tabulation faster or memoization faster or basic Fibonacci approach faster? Thank you guys. Thank you so very much.